I'm sorry, let's continue. Press the wrong key. Yeah, actually, let me pause for a minute. I need to. Okay, let's continue. All right. And let's go back to our PowerPoints. This is a symbol system for Mayan numeration system. Cracking the Mayan code. Here, you got to know table 4.2 to find numeral and positional value. Let's say if you have these symbols, you want to find what does this number means in our Arabic numerical system. You got to go, if you have to go to page 198, table 4.2, it tells us that this symbol, it's a value for, where is it? Okay, yeah, it's here. Value for 12. This one is value for 1. This one is value for 0. Okay. And this one is value for 1. So we got our digit 12, 1, 0, and 10. Then you got to know their positional value. Again, these are just given to us. So don't try to figure it out, but just this is given to us. This is, if it's in a, here, we go from this, from bottom to the top. The first position is multiplied by 1. The second position is multiplied by 20. The third position is multiplied by, actually 360 or 400 to make it easy. And the fourth position is multiplied by 7,200 or 8,000, just approximation. So this is the value. This symbol means this, 96,410. So again, you look at the table, you find what each of the symbol of value. This is for 0. This is for 12. Okay. Then you find their position from bottom to the top. The first one is multiplied by 10, by 1, I'm sorry. The second one by 20, the third one by 18 times 20, and the fourth one by 18 times 20 to the power of 2. Okay, this is just the way they have their numeration system. If example 5, you look at example 5 of same page, 98, 90, 198, 199. For example, just look at number 8. You find the equivalent of those symbols. You have the Mayan numeral, for example, the top one has 4 dots, and please look at your textbook. 4 dots and 2 parallels. You look at the table 4.2, that's 14. That little, like an oval shape, is 0. The 2 dots and dash below it, it's 7. The 2 dots and 2 dash below it is 12. Okay, so we find our equivalent numeral digits. Then you have to find, multiply by the place value, and you start from bottom to the top. That's the first place. You multiply by 1, second one by 20, third one by 18 times 20, and the fourth one by 18 times 20 to the power of 2. You do the multiplication, you add them all together, you get 100,952. That's the answer. Same for example B and the other ones. All right. Greek numeration, again, in many cultures, different alphabetical alphabet have different not only symbol and pronunciation but numerical value. Alpha number 1, beta number 2, and so on. Roman numeral system, still you use it to some extent. You look at it, it tells you, for 1, for 5, 10. These are the major ones that we use, and then the rest are all here. For example, 154 is equivalent to CLIV. Why? Because if I go back, 154 is C is 100. Now, what is 50? Is L, CL 50, and what is 4? 4 is right here, IV. So you have to write CLIV to get 154, which is very difficult task when you want to do large number numeration, and that's why these systems don't work. Think of this one, 1,492. Now, how do we know this is that? It's because, let me write it down for myself, 492. Let's go back to the table. Okay. What is 1,000? Where do we find M? Here. M is 1,000. So you get M. There you get 1,000. Then C is 100. But we have 400, so we need 4 of them. M, C, 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 C. 492. 90 right here. Show you. Where is it? Right, 90 is here. X, C, and number 2 is right here. I. So that's why you get. Oops, you get 1,400. Then you have 400 LX 90, and you get again 4,090 is right here. Let me show you right here. 90, this is 90x, and then 92. You add 2 to it, so you get that. XC22. So you just go back to that table and find the equivalent in the Hindu-Arabic system. M, C, 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 LX, XXX22. Or 3495 is equivalent to 3,000. So you need 3M, 400, 1, 2, 3, 4, 95. 95 again. Let's go back. 90 is here, XC, and 5 is here. V. Okay. Hebrew numeration system, they also have numerical value, but it goes from right to left. That's the only thing you need to remember with Hebrew numerical system. For example, they don't have a base, so they are not really a positional numeral system any more than Roman numeral. Number 764, 764, if you want to, that number in Hebrew is this, but you got to remember, you go this way. Let's go to our table, 764. This is, where is 700 actually. Multiple of 7. So okay. Here is 764. you have Sumac, Shin, and Tal. So you go, let me find the number. It's Tau is 400, then Sumac 400, then you needed 300. So you see, you go from right to left. You go from opposite of what we go. 400, then you have this, with this 700, then you have 40, the here, actually 60, so Sumac, and 4, the number 4, which is right here, Dalt. Okay. So you start from here. This is 400, 300, 60, and 4. The value is calculated 4 plus 60 plus 300 and 400. Okay, I hope you're following. Any counting number greater than 1 may be used as a base for a positional value numeration system. If a positional value system has a base B, then its positional value will be B4, B3, B2, B1. For example, positional value for a base 8 system, the base is 8, then look, see, this is 1, 2, 3, 4, 5. So n minus 1, this is the 5th position, 8 to the power of 4, 3, 2, 1, 1, and 0 is 1. Positional value of 2, the base is 2, and then this is the 5th position, this is the 4th position, this is the 2nd position, 1st position, and 1st position, this is actually, 5th, 4th, 3rd, 2nd, and 1st will become 1 because n minus 1 is 0. Computers and electronic devices use 3 different numeration systems. Binary, base 2, 0, 1, octal, base 8, and hexadecimal, base 60. If you want to convert from base 6 to base 10, for example, let's give you a number 453, but it's base 6. We want to convert it to our own numerical system, the Arabic numerical system, base 10. So, again, 4, 5, and 3. Just write the digits 4, 5, and 3. This is base 6. This would be 1st position, 2nd position, 3rd position. First, n minus 1 is 0, so it's times 1. The 2nd, this is base 6. 2nd minus 1 is 6. 3rd is 6 to the power of 2. So you just multiply all these numbers. So 453 in base 6 is equal to 177. From converting from base 8 to base 10, again, if you have this number is given to you, 3,603,615. Actually, I shouldn't read it like that. So just write the digits 3, 6, 1, and 5. 3, 6, 1, and 5. We are in base 8, so multiply by 8. But again, remember, this is the 1st position, 2nd, 3rd, and 4th. So the 1st position, position 1 minus 1 is 0, so just multiply by 1. 2nd position, 2 minus 1. 3rd position, 3 minus 1, 2, and so on. Just multiply and add them together. Converting from base 2 to base 10. Now, we want to do the other way around. This is the number that we have in our own system. We want to convert it to base 10. In base 2, the positional values, are the 2 to the power of 3, 2 to the power of 2, 2 to the power of 1, and times 1. So we have this number. This is base 2. Okay, we write all the digits 1, 0, 1, 1, 0, 1. 1, 0, 1, 1, 0, 1. Their position, this is the first position, multiplied by 1. Second position, multiplied by 2 to the power of 1. Third position, multiplied by 2 to the power of 2. Third position, multiplied by 2 to the power of 3, and so on. And that's you convert a number in base 2 to number to base 10. Okay. Let's see, review example, checkpoint 3 page. Checkpoints 3 to page 102, 204, 206. For example, if you look at page 204, example number 3, it said given a number EC7 on base 16, says convert that to base 10. And it has given us the additional information on the side that E represent what, C represent what. So we have E7, EC7 base 16. E represent 14. So we have 14, C is 12, and 7 is 7. Now, base 16, so we'll multiply them by 16. Again, start from the right, that's first position, multiplied by 1. The second multiplied by 16 by the second position is n minus 1. Third position is n minus 1, 16 to the power of 2. Exactly the same. Nothing different. Okay. Okay, let's look at example number 5 on page 205 of your textbook. It says convert the base 10 numeral 299 to base 8 numeral. Okay, base 8, the positional value are this: a to the power of 2, a to the power of 3, a to the power of 1, and so on. In order to convert from our own numeral system to base 8, we take the number that is given to us, 299, and divide that by 64. The place value that are less than 299 are 64, 8, and 1. That's why we are dividing it by, so you have to find a place value which is less than the number that is given to you. The place value that we find less than the one that is given to us is 64, because anything more than that, it will be more than 299. So we divide it by 64. When you do the division, you get the remainder of 40 and quotient of 4. Then you take the remainder and again divide that by 8. Again, you get the quotient of 5 and remainder of 3. So you take these three numbers, 4, 5, and 3. You write them. 4 in position of 3, the third position, 5 in the second position, and 3 in the first position. And you multiply them, and you get the number in the base 8. So again, a number is given to us in base 10, our numerical system, 299. They tell us convert it to base 8. The place value in the base 8 are 8 to the power of 3, 8 to the power of 2, 8 to the power of 1, and so on. You have to find the number that is less than the number that is given to you. 8 to the power of 3 is more than that, is 512. So the nearest number that is less than the number given to us, the nearest place value is 8 to the power of 2, 64. So we divide 299 by 64. When we do the division, we end up with a remainder 43 and a quotient 4. So 4 groups of 64, that's what it means. So you take the remainder and divide that again by 8, you end up with a quotient of 5. 5 groups of 8 and 3 ones are left over. So 3 ones are left over. So it's 3 times 3 goes to position the first position. 5 goes to the second position, the 5 groups of 8. 4 goes to third position because it's 4 groups of 64 or 8 to the power of 2, which gives you the number 453 base 8. I hope this is clear. And basically the rest are the same. So I'm not going to, I mean, I shouldn't say that. I'm not going to ask you to convert numbers on the test or quiz, but you got to know these things. You got to know how to use expanded format, and you got to know, you know, please, no, I take it back. Please read and study these, but you don't need to know, I put it there, but you don't need to know how to multiply or divide in other numerical systems, in different base systems. But please know how to convert a number from different system to our system or from our system to different system. Okay, that's the end of session number 2. The Lord bless you all.